Hi everyone, my name is Becca, and we are here to talk to you about the Blue Sky Studios USD and Conduit pipeline. Over the course of one production, we cut over our entire pipeline to USD and changed our versioning control system to Conduit. In that process, we had learned a lot, and we are going to share some of the highlights and pitfalls we faced over the course of this transition. Before we dive in, let's review some terminology. Think of a product as a version-controlled directory of production content. The behavior of products were defined using archetypes. There were many different types of products, however, the majority fell into three major categories. First, entities, such as assets, shots, or scenes, were aggregations of element products. Elements were products that contained discipline-specific contributions. For example, an animation element contributed to a shot entity. We'll dive into this more later. Workspaces were products where artists created and versioned their working files. And finally, PRIs were the unique identification or the address for each product, analogous to file paths.
Hi, I'm Chris. Let's dive into our asset structure and how we incorporated USD into Conduit. As mentioned earlier, an entity is made up of element contributions. Entities were shots or assets, but for now we're going to focus on assets as examples of USD and Conduit working together. Organizing contributions into element products allows for parallel discipline-specific workflows and contributions to each asset entity. So you can see here we have a little teapot and all of the disciplines that contribute to it. There was very little enforcement that each element strictly included the data that corresponded to it. For example, no tooling would check that models didn't include lights, but it did suggest what types of contributions, what types of data you could find within. Usually this was in the form of USD data, but other data could be found as well, such as texture maps or Maya rigs. Each entity and element had a USD root layer. The element USD layers were sublayered into their entity's USD file. The strength ordering was defined and enforced by the entity archetype, which reduced the number of opinion strength issues to debug because artists couldn't accidentally change the ordering of element layers. This also allowed for parallel contributions, but communication was still important. We had tooling to validate data to make sure that it wasn't egregiously or obviously incorrect, but production complexity dictated that artists still needed to talk quite a lot with one another and communicate changes that were happening in order to work in parallel with as little friction as possible. We used USD kind metadata extensively to organize our assets. This let us leverage some USD features, but a big win was that it was similar enough to previous and existing organization of our assets and how asset departments were used to working that it was a really nice part of the new pipeline. So the two main kinds that we had were components and assemblies. We defined components as having a payload and that they had self-contained geometry. Assemblies, on the other hand, were aggregate assets that were assemblies that aggregated and referenced together other published assemblies or published components. We extended the model kinds available to provide more options to describe our scenes richly, especially for departments like lighting. These were important distinctions so that they could filter their render layers as efficiently as possible. We had tools as well as education materials that helped enforce model hierarchy. This was where we reserved the group model kind just to enforce model hierarchy. We never published any assets as a group kind. So two goals of our component assets was one, that they would all have a payload, but two, we wanted them to be as efficient as possible right out of the box. Our solution was to have, instead of having the component root prim itself be instanceable, we actually instance a child prim. And that child prim is also where we anchored our USD payloads. To convey this meaning, we named the prim payload so that artists could understand that when contributing to a component payload, there was a good chance that, if not a 100% chance, that at or below that prim would be instance and therefore hands off from direct manipulation. It worked really well. Did cause some confusion about what a payload meant and how payloads worked with USD, but overall we were pretty happy with how it worked out, because it gave us independent material variants, which were independent from geometry variation, but also our lighters could add lights into assets that would be broadcast, anywhere that this asset was referenced, and they could work regardless of whether payloads were loaded or instanceable. All of our assets inherited from class prims. These class prims we organized based on the tokens of the PRI from each asset entity. Variance was a concept that we were excited to adopt. We did so under this umbrella term core variance. What this convention simply meant was 3 variant sets that were always present together: model, resolution, and representation. This helped establish a good baseline for artists and TDs of what to expect in our assets, because almost every asset had core variants. And so they understood what they were getting, and they also understood what they were contributing, which was almost always a core variant or through core variants. We added some metadata on products as well to understand what core variants had been authored, but we also organized the core variant contributions into subdirectories within the product, and this helped with tooling. It also helped with some debugging, and it was a nice kind of first experience with USD variants. Artists were absolutely free to define custom variant sets as needed, whether this was within the umbrella of core variants or independent of it, but they at least had that core variant concept that they could rely on to start. So what were some other takeaways from incorporating USD into Conduit? One was that some adjustments were needed by many departments because this idea of variance was new. Previously, a model variant was a unique asset and a unique entry in the pipeline, and so it was scheduled accordingly, and artists thought of them accordingly. But now that an asset can have multiple variants, and these variants might be just as much work as a unique asset, required a little bit of different thinking by production management and by artists. And departments needed to think about variants and what their contributions meant, what it meant to have a variant for them, because some departments variance was not a big deal at all, and was just a natural extension of existing workflows. Variant choices need to be available outside of USD as well. We were working towards variant-aware product browsers and tooling for artists to reference an asset entity, but also make selections, variant selections as well. Our prim structure caused some problems for selection because the root USD prim was not instanceable and wasn't the payload, but most of those have been worked through and cleared up. And finally, animation and rigging required some changes because they relied on hierarchy as a tool, as an interface, which was a problem for USD. So we had to implement some tools and some restrictions around that to help ensure that our USD scenes remained composable and didn't break.
Hi, this is Tim. Next, we'll talk about where the fail-forward design philosophy of our pipeline conflicted with the sparse nature of USD overrides and how we were planning on addressing the issue. We'll walk through the most prominent example of this conflict, which was propagating breaking topology changes from assets to scenes. Let's dig into why topology changes were an issue. At the asset level, geometry was fully defined in USD. This included point positions, topology information, and some USD prim vars. When referenced into scenes, animation on these assets was stored sparsely, only overriding properties that changed, normally transforms and point positions. This representation was fast, compact, and allowed changes to the asset to flow automatically into scenes. That was unless the change altered the topology of the asset. This would lead to broken geometry in scenes because the point position overrides would not line up with the new topology of the asset. In order to fix this issue, we would need to recalculate the overrides in every affected scene. And without proper automation, this led to a costly, manual process for artists. To help insulate scenes from these breaking topology changes, our plan was to introduce a new unit called collectors. Collectors would be locked down versions of assets that would freeze dependencies and potentially flatten USD data down to a single layer. With these collectors referenced into scenes, renders would remain stable and artists would be able to choose when to absorb breaking changes. This solution isn't perfect, as we would lose the flexibility in choosing specific versions of asset elements in scenes. However, we found that artists often don't want this control and complexity in their workflows. In the end, stability is more important.
Hi, it's Becca again. Transitioning to the new pipeline, we were challenged to find the right balance of complexity and control for the artists. Next, we're going to dive into a few notable examples of this. In Conduit, we made the conscious decision to stay away from artist-facing UUIDs. Instead, we used a PRI composed of three main components. The entity portion, which denotes a concept like asset, shot, or sequence. The category portion, which can be thought of as the product type. And the product version, which can either be an immutable numeric value or a mutable label, the mechanism behind our push pipeline. More on that later. So in practice, this is an example of what a PRI for an asset looked like. And this is how they were in a USD file. As you can see in the USD file, it is easy to see which elements are sublayered into the asset. The tokens in a PRI were human readable, allowing artists to make an educated guess on what they represented without having to consult a tool. They could easily be shared over Slack or email and ingested into our own tools and DCC tools via drag and drop or copy and paste.
Howdy, I'm Ryan. Workspaces are a special product archetype for an artist to manage their precious source files. This meant they were assigned a different flavor of PRI. As you see in these example PRIs, workspaces were only specific to a project. This put the burden on artists to name workspaces so they could be identified and discovered. This created some problems. First, with no explicit hierarchy, tools like Hub could only present workspaces in a long, flat list. Second, artists were forced to combine all contextual information into long, illegible names, which hindered the discovery. And finally, some artists preferred to use only a few workspaces to complete all assigned work. This was an intended option, but it meant a single workspace would become the source of many output elements. This eroded the utility of tracking the relationships between output and source, and created uncomfortably large workspaces. Because they had not been used yet, we initially designed workspaces to be as generic as possible, accommodating a variety of workflows. However, in practice, we found that a majority of artists gravitated to a more focused workspace. A better design would be to create each workspace within a specific context to better support that 90% case, falling back to a project-wide context only when circumstances or preferences required. The resulting PRIs followed an established granular pattern and also addressed the discovery issues.
Hi, I'm Oliver. Dependency resolvers are at the heart of the Conduit pipeline design. We're going to look at some of the tricky but also quite powerful parts of that. Labels acted as aliases for specific product versions. The purpose of the label was to propagate the change through the pipeline. Our initial implementation employed three labels: latest, published, and approved. As mentioned previously, we use these to facilitate the push mechanism in our pipeline. So updating a product's label would propagate the change to all its dependents. However, these labels and their implied meanings were also a source of confusion. Specifically, the label approved, which was meant to indicate the most stable version of a product, was often mistaken as a certificate of approval, which caused some misunderstandings. So that bit us. To get around the problem, we decided to remove it and introduce a workshop label. To clarify their purpose, we also started to think of the three labels in terms of their intended audiences. The latest label was for the author of the content, and it was used by them to be able to see their work in context with downstream products. The workshop label was for collaborators. So for example, a modeler could use it to work together with a rigger or a material artist on an asset without sharing their work with the rest of the production. And finally, the published label, which was set on a version of a product that was intended to be used by the production at large. Now let's dive into some dependency resolution. We did not have a version specifier in our paths. We specifically excluded it so that all references in content were only at the product granularity. As you can see here in the USD file, it has no version numbers or labels in the sublayer file paths. Conduit figures out what specific version of a product should be used based on the resolver set in the artist's workspace. This had some interesting benefits. It helped us with our push pipeline since we do not have to update paths and content. And it also helped us to avoid diamond dependency relationships since ever only one version of a product could have a given label. However, because of the flexibility of dependency resolvers, there was still a lot of complexity for the artists to understand. Let's dive into some of the confusion that occurred. Our tools gave the artist the ability to create overrides to any product at any level of the dependency tree. This provided a lot of flexibility, but as said, caused also confusion. For example, an animator having a dependency to an asset could individually override the material to a version 6 or maybe the rig to latest. However, if they forget they did that, without looking at the asset's elements, it still looked like they should be seeing the published version of the asset. But of course, they did not, since the parts of the asset have been redirected to other versions. The crux of the problem was that for entity products like assets, artists expected them to be more consistent with what the product's version numbers or labels implied. For example, when looking at an asset in the context of a workspace, if its dependencies updated, it looked different than when looking at it in the repository, which displayed the state in which it was originally committed. However, the expectations when looking at a labeled product like that, because of the label in the PRI, what should have been shown was the current, meaning the re-resolved state of the product rather than the snapshot in time. This was different for numeric versions of a product for which displaying the immutable snapshot was the right choice. Even though this is an inconsistency in Conduit's behavior, it turned out to be more intuitive to users.
Hi, I'm Karen. Transitioning Blue Sky Studios to a new pipeline was a learning experience for both artists and developers. Throughout this transition, we evolved our USD structures, artist workflows, and tools to simplify the artist's user experience. It was a massive undertaking that could not have been possible without the support of both production and technology. We learned a lot. Production trusted us with this endeavor, so it was crucial to make sure artists and production management had avenues to provide feedback to technology. We began with user story sessions, transitioned into regular sprint reviews with key production representatives, and then began our pipeline user groups, or PUGs as we called them, which allowed artists to tell us real-world examples of workflow issues they were experiencing. Artists also needed support, so we had daily office hours where an artist could come in with a problem and work through it with technology. We kept these up even when remote work began, holding office hours over Zoom. Our work would not have been possible without the amazing artists, TDs, engineers, and production management at Blue Sky Studios. There was still much left to do at the time of our studio's closing, but after finishing our first production on the pipeline, we feel like we are off to a good start.